Greetings. Oh, hi. My name is Mike TEWZ. This is Izzy. And this is my entrance to the Moog Fest 2016 Circuit Bending Challenge. My buddy gave me, thanks Rob, this YAMAHA Portasound PSS 140, and I think it's going to be a really good candidate to bend because, one, it's got drum pads, it's got drum sounds, drum beats, and then it's got 99 different preset sounds, which range from pretty cheesy to kind of interesting, like this fireworks sound. I did a little research, and this Yamaha Portasound actually has a IC chip inside. Okay, so this chip here, the Yamaha YM2420, that's actually a FM operator IC. It's pretty interesting. So anytime on the front you want to select a sound, say accordion, you hit enter. The CPU is sending data over 8 lines to the sound chip, and that's telling the IC what sound to pull up. All those parameters, and if you look at the data sheet for the chip, you can see what the chip controls and what it won't control, but it actually has decay, attack, and modulation and some other controls. The common bend is to cut the data lines between the CPU and the FM chip, installing switches, thus disrupting the flow of data from the CPU to the FM chip and creating new interesting sounds since some data is being omitted. So the idea is to put a patch bay so you can route any of the 8 data outputs to any of the 8 data inputs. Okay, so really quick, I just wanted to go over this circuit that I have here. This is a 555 timer IC and a CMOS 4017 counter divider circuit. And basically, there's a bunch of outputs on this counter chip, and it's being driven by this timer, and this potentiometer is controlling the rate of the LEDs. So if you see, this is now basically a sequencer. And so on the Yamaha, there are some drum pads for drum sounds, and I was thinking that I could add some kind of drum sequencer so you could sequence the drum sounds. So right now I just wanted to go over this little sequencer. It can go up to 10 steps, but I have it at 8. In addition to it being a LED sequencer, the 555 is also a square wave oscillator. So if I plug into the input of the op amp on the keyboard, you can hear the square wave oscillations. I have been trying to get the LED sequencers to program on the other side of here. There's drum sounds. So I found the individual drum parts, which are right here. There's 5 drum sounds. That's the kick, one of the hats, the snare, tom, and another hat. I don't know if you can see here, but I have a bunch of NPN transistors. So I'm using those as switches out of the outputs of the 4017 IC counter to drive the drum beats. I was having problems being able to use the LEDs to trigger the sounds of the Yamaha without having them all connected and it just not making any sound at all. I switched the combination, I adjusted, and now it's working. So if I get the kick on the one here, if I do this, this distortion. I just wanted to show this distortion. So, and I was messing with the power, trying to get it to work, and I had it connected to my LED module, and I don't know if you could see right here, but I blew up my 4017 counter. So that sucks, because now I have to resolder this whole thing, and I only have about 2 weeks left, and I just lost a day, and I'm pretty bummed. So I got the synth taken out of the original case and put into this plastic case. I'm trying to figure out right now where stuff goes so I can start putting this in. I went around the house and found a bunch of scrap wood, and I also found a piece of plastic, this guy right here. So I'm probably going to use that, and I'm just going to cut all this stuff up and try to fit it in here. Okay, so I have cut out some pieces of wood to run across the case so I can attach some stuff to. So I'm going to have to unsolder this and solder another ribbon to connect these two pieces. And I'm going to move this up to the top. I'll have a input for the power if I drill a little hole, and for a 1/4 inch. And this makes the perfect amount of space for this. It's a control panel. I used to have a boat, and I actually found this where I had my boat docked just in a bucket with a bunch of other stuff that was getting rained on. It's got these holes drilled for fuses that are connected on the back that I want to take out, and I'm thinking that this can be the entire control panel for whatever device I end up making. When I cut the keyboard to fit into the case, you could see into the sides. I didn't like that, so I glued the ends back on, sanded it down, and painted it. I attached a longer ribbon between the top and the bottom, and now this bottom part is removable. I'm going to put a back on it. And that's good because the battery compartment's here, so I don't need another battery compartment. I can just use this one right here. And I cut a little slit right there so this ribbon can slide freely underneath. Okay, so I just got this little module from Circuit Benders in the UK. It's an LTC 1799 precision oscillator module. It comes mounted to this little PCB because the actual IC is super tiny right here. I really like this one because it has an onboard limiting pot right here, and A, B, and C. The way I have it connected right here, B to C is divided by 1. When it's open, it's divided by 10, and A to B is divided by 100. The way you connect it is really simple. You have two lines that go to a pot. I'm using 100K. One line goes to ground, and the other point goes to +5 volts. So I have a voltage regulator down here. Then the output goes to the X-tal of whatever device you're bending. So it takes a normal sound and pitches it down. So you have super slow clock speeds. Okay, so I moved the speaker down to the bottom. I detached this switch and attached the power to the control panel. I got the module all hooked up, and I put a switch here for the divisions. Okay, so I finally got this echo circuit working. Here's how it sounds. Okay, so I finally finished soldering the circuit together, and I have it working with the LTC 1799 precision oscillator, and sounds really crazy. So last night I had everything hooked up, and the delay wasn't working. I desoldered everything. It was a bad IC. Somehow in my tinkering, I destroyed this chip, and I had to desolder it from the circuit, and now I got to rebuild this whole thing, which sucks. That's where I'm at. It's Wednesday. I got 4 days left. I'm at the thrift store, and I just found this old calculator for $2. It's awesome. Okay, so this is the LED display from the calculator that I found at the thrift store. It was left over after I cut it in half. I messed with it earlier and I couldn't get it to work, but somehow I figured out how to get it to display.